Hello, my name is John Sayre, Technical Marketing Manager, Civil Infrastructure here at Autodesk. Today I would like to talk about a workflow for road rehab. This third of 3 videos will take you through how to navigate this workflow. This is step 3 of 3, using the road rehab corridor. In our last video of this series of 3, we left off after we had created our linear features and our transverse features, and we exported our information out so that we could bring it into Civil 3D and start to use it with our road rehab corridor. So let's jump over to Civil 3D and we'll just get started. We're going to start from scratch here. So the information that we're going to bring in is the information that it exported from InfraWorks. So we've got our RCS, which is our lightweight point cloud that is showing our bare earth topo. Then we've got our shapefile for our linear features, and we've got our transverse points Excel point file. First thing we want to do here in Civil 3D is we want to go ahead and set our coordinate system. It's very key that we make sure that we're using the right coordinate system. So I'm going to go ahead and select the coordinate system that is applied here for this project. It was Alabama West Zone US foot. I'll hit apply and OK. And we're ready to start bringing information in. So the first set of information we'll bring in is we'll go ahead and bring in the linear features that we extracted. All right, so we're going to do that by using the map import command. We'll just type map import at the command line. And we will select our shapefile. Couple things we need to make sure of. We need to make sure it's in the right coordinate system. All right, so if it says something different here, you need to go back and check how that was exported. And we want to be sure to select here in the data area and have it create object data on those lines. Hit OK, and they come in. We'll zoom extents and you can see that all of the linear features came in. Now you can see there was one that has a gap. All right, and I told you that maybe sometimes the linear features they run out of data and you have to just start over. So that's what I've done here. I ran out of data here and I started back here. All right, so the next thing we'll do, we've got our line work in. So next thing we'll do is go ahead and we will create a surface. So we're going to generate a surface called EG for existing ground. And we'll change our style to a 1 foot, 5 foot interval of contour. And we could actually bring in those points in that CSV that were generated as the transverse features. We could bring those in as physical points, but they're still on this particular job, and this is quite a long roadway. It's about a mile or 2 miles of road that we're looking at here on the rehab project. And I don't want to bring in 100,000 points because it does affect your performance on your machine. So I'm going to actually just attach the point file that it created, that CSV, and I'll go out and pick that transverse features point file. It's going to come in an E and Z format, all right, easting, northing, and Z elevation. You can see the preview here, and I'll just go ahead and hit OK. And it's going to generate my surface for me. So once this surface is generated, I can see my contours. You can see just a little bit of interference here that was in the point cloud itself. And we can kind of get rid of that interference a little bit if we go back and reset our transverse lines, how it was sampling along those lines from a half a foot to maybe a foot or 3 feet. It's just an iteration process on this particular point cloud, but it will take that interference out. That still looks very, very nice. If you run just a line across this so that we can see how the surface is actually shown or actually been generated, we can go to quick profile and I can throw a quick profile out here and you can see that interference, but you can see the roadway looks fantastic and that barrier shows up very, very nicely. I'm going to go ahead and zoom back. You can see that I've added a boundary. I just want to use just this amount of surface. So this information here, I've just basically capped it off by using a boundary. All right, so I'll go ahead and save my drawing. We're ready to start talking about the road rehab corridor. We've got everything in that we need. So a couple things we need to do before we actually apply the corridor, or one thing we need to do. These features that come in, remember I told you there was object data on them. So I could grab that linear feature, I can go to the properties of that, and you can see the feature code inside of it. So EOP1 was what we set it as. That comes in as object data whenever we bring in the shapefile. So I'm going to go ahead and select the next one. It says PS1, we have PS2, and then PS3. All right, and then I think that that is edge of pavement too. All right, so remember we had that break, and I need to figure out which one of these lines I want to use as my center line of the road or my center line of my alignment. So I'm going to use this broken piece here so I can show you how to fix this or how to work around it. So I'm going to use a command under the Modified tab of the ribbon, convert 3D to 2D polylines, because remember these are 3D polylines that have vertical elevations that are different along that point cloud at each vertice. So I'm going to grab these two and hit enter, and they just basically went to one elevation. So I'm going to go ahead and go to the properties. I'm going to change that to a 0 elevation, and I'll change this line to a 0. So all of the vertices now are at 0, and I can simply connect the two and then run the pedit command and pedit them together. Now you wouldn't necessarily have to do this step. You could just generate the alignment from the two pieces, but I like to have one line whenever I'm generating an alignment. So I'll grab this alignment, I'll move it back up into my surface here because it is hanging off a little. And I'm going to go ahead and create an alignment. So I'll select, create alignment from objects, and we will name it. All right, and I'm just going to call this CL Road Rehab. And I'll turn off my conversion options, and I'll go ahead and have it labeled a major and minor station so I can see where I'm at. Last thing before we can start to run the road rehab corridor is we need to generate a profile that shows our surface, our existing ground surface. This needs to be in the drawing so that it can actually pull vertical elevations when it's running the assembly down the alignment. So I'll go ahead and hit next and create and throw that out there. Now, you can see where I chopped off the surface, all right, with my boundary. But let's zoom in and look, and this is a very nice, smooth line, all right? What we see sometimes in surfaces that are generated from a cloud is they look a little jagged because there's so much information there. And this gives us a very nice, smooth profile line for that assembly to follow. So it represents the roadway very, very well. Now what we're going to do is we're going to generate a road rehab corridor, and we're going to target each one of these paint stripes as a lane, all right? And show you a little bit about the parameters and things of that nature that we can set up inside the road rehab corridor. So we'll go up to corridor, and underneath the traditional corridor selection, we have road rehab corridor. We'll just call this road rehab. We're using our center line as our alignment in our EG profile. And I'm just going to start this. I'm going to move it up just a little bit to say station 200, and I'm going to stop it at station 1000 just for this particular demonstration. And I'll hit OK. Now, it's going to open up what looks much like the corridor editing dialog, but this is where we set up the road rehab parameters. All right, so you can see here that it's got 3 viewports that it's broken our information out into. And I can look here at viewport configuration, and I can change that if I'd like. So I can move, the plan view to viewport 2 and the profile to viewport 3. I can change the layout. I could have 4 equal viewports, so on and so forth. This is personal preference, totally up to you. I'll go ahead and hit OK, and it moves those around a little bit. I think I moved the plan to viewport 2. So we'll be targeting here in the plan view of viewport 2. We see here a cross-section view, but it's empty. So the road rehab corridor is going to generate our assembly for us according to these parameters that we set right here. So we know that from our linear features that we extracted that we're going to be targeting these lanes. So the default width that we see here, I can go ahead and just leave that. We have targeting options for the inside edge of lane and the lane width. All right, so we have targeting that we can set for either side of the lane. This is key, okay, because whenever we add the second left lane here in the plan view, all right, you see there's one lane here and going to be one lane here. We will target this feature line twice, all right, this linear feature twice, or that polyline that it generated from the linear feature. So I'm going to go ahead and just hit apply, and we're going to start to see some information come up. All right, it generates that particular assembly that we're using as of right now. It builds that for us. Okay, if we wanted to see what that looked like, we could I can jump here into my profile viewport, and I can move down in my prospector tab, and I can select the assembly that it generated, right click and go to zoom to, and you can see that it's built it for us here in our plan view. And you know what, I'll just leave that there for right now. So next step, I want to add my second lane. So if I look at my rehab parameters, I can add as many lanes on the left and the right as I want. So I'm going to go ahead and just tell it I want 2 lanes on the left, and you see that it added it here in my assembly automatically. Okay. Notice that the widths and the slopes are all set according to the defaults that were here in the rehab parameters. So once I've got that built, if I wanted to see it inside of the cross-section view, I simply hit apply, and it rebuilds my corridor, and you'll be able to see all of the lanes. So we can kind of step through this, and it's kind of a what you see is what you get type of environment. So I'm seeing this information here. It's in a level only vertical adjustment type for the road rehab input. So we're only looking at a leveling type scenario. We'll leave that there for right now. We're going to go ahead and target first. So I want to get my targeting out of the way. So I'm going to zoom in here so you can see this corridor just a little bit. That line right there is what we're going to target with this edge of my lane. So if I touch that part of the corridor, you can see it highlight here in my cross-section view. So I can just touch that and you can see it highlight. All right, so that's the parameter that I'm going to set first. All right, so I'm going to zoom back just a little, and I'm going to go over and select my LL1 lane. I want to make sure I'm working with the right one, and I'm going to target the edge of that lane, so the width. So I'm going to go ahead and select the polyline from a drawing, which is right here. And I'll select that polyline and hit enter. And I'll hit OK. And you'll see after I hit apply that it moves that magenta line and that piece of the corridor over to that edge. Now, we've still got a piece here that's kind of crossed over. So that is the inside edge of the second left-hand lane. If you look here in the cross-section view, you can see that they overlap. All right, we're going to fix that real quick. All right, so first thing I need to do is change my display order so I can actually pick the line I need. And that edge of lane, I'm going to stick to this line. So that is going to be the LL2 lane we're working with. And we're going to use the inside edge of lane target selection. I'll do the same thing. I'll pick that feature line from my drawing. All right, and I'll pick that feature line or that polyline, and I'll hit OK. And it moves that over after I hit apply. So once I've applied that, it's going to move that lane over. All right, now they're overlapped exactly the way they needed to be. All right, and if I look here, you can see that they match up very, very nicely. You can also see that we've got a different width on this first lane. It's 12.64 feet and not 12 feet. All right, and that's only at this particular station. So we'll show you that in just a second. So I'm going to go ahead and I'm going to target the outside edge of that lane, that LL2. So I'll hit select from drawing, and I'll go ahead and pick that lane that is represented by a polyline. Hit OK, and I'll hit apply. All right, so now the corridor is covering and stretched to the exact limits of our linear features that we pulled in InfraWorks. You can see that those characteristics are being taken into account for. You can see there's a 12.64 width. The slope is negative 1.54, and that's changing according to some of the road rehab input that we have already set up here. So we've got that ideal cross slope set to negative 2%, and we've got a tolerance on that of 0.5%. So what if I change the ideal cross slope now to negative 1.5% instead of 2? This is where it starts to take into account for some of these rehab parameters. And this is the iteration and the design portion of the road rehab corridor. So every road's going to be a little different. You're going to have parameters that you're trying to stick to for that particular rehab project. And you can see that it's been taken into account for here in our cross-section view now. We could move up cross-station view, or we could move up cross-section station. We go to station 2 plus 50, and you can see this is what we have at that point. So the width changed a little bit. So it is moving and sliding down that corridor according to that particular feature line that it's hooked to. Now there's one more line over here that we could apply our targeting to if we wanted to, and that's the right side lane. All right, so I can, that feature line that was brought in is right here, so I could change my lane property to RL1, and I could target that lane width the same way that I did the other two on the left by selecting it from the drawing and picking that polyline, hitting OK, and then hitting apply. And it adjusts the right lane to follow that feature. All right. So a couple other things. Just to quickly hit on the rehab input, we can change any of this according to the design that we're trying to put on the roadway itself. So you can see that once we make a change, so I'll make this back, or I'll set this back to -2%, and our tolerance is 0.5%, so I hit apply, and it's going to adjust that all the way down my corridor, and you're going to be able to visually see it here in my cross-section view. So that -1.95% is within the 0.5% tolerance, so it leaves it. And if I don't, if I see my exclamation point come up here, which is a warning, I can hover over that and it tells you that the actual slope difference is greater than the slope tolerance. So the slope difference is -0.55% and the slope tolerance is 0.5%. So we've got the corrected slope that it gives us, and that it's not equal to the ideal cross slope. So just gives you some warnings that you can go by. We can build this for different vertical adjustments. So I'm showing you a level only here. If I change this to mill only and then hit apply, it will give us a milling condition for the entire corridor instead of the leveling. So you can see that it's taking into account for that existing ground and milling it down to a specific elevation. And you can see at each edge, at each point, what those milling depths are. This can be controlled differently, so we can label this differently in our code set style. So we don't, out of the box, this is what it gives us. So that's what we're going to run with today. So we could actually change this if we wanted to a mill and level, and it would give us the same information up here in our cross-section view, but just show a mill and level condition instead of just a mill only. All right, once we're happy with our corridor and the information that we've got in there, all right, so the last thing that we'll talk about is the Rehab Manager. So if I select the Rehab Manager, I can actually edit the accepted slope on these particular lanes. So I'm going to move this over, and I'll show you real quick. I'll shrink this down so you can see a little bit better. And you can see I can select a station. So if I select 2 + 25, it goes to that particular cross-section view. So on my left lane 1, that's what I want to focus on. I can turn the other lanes off and I can look at it here. And the accepted slope, if I look, is 1.93%. All right, so I can actually double click in here and say that's -2%, and it will update that section. All right, and you can see there's green values, and that means that there's basically user input. All right, and that it has been overridden. So we've overridden it at that one particular station. I can drop to the next station, do the same thing, or I can just look at, you know, my different stations here and say, you know what, this station is station 2 + 65, 47. I need that to be the -2%. So I can just make it -2, and it would adjust it again and adjust my mill depths also in this particular case. Now, I have a nice milling and leveling report that I can look at each individual edge point. All right, and again, this is using all of the lanes, so right-hand lanes, left-hand lanes, or meaning left-hand 1, left-hand 2 lanes, and the R1 lane. So I can take a look at this report, and it gives me a very comprehensive view of what's going on with my road rehab corridor. Now, the last thing I'll show you is this report that we can build. We can actually select export a report. I can export an XML file. So if I go here to, we could build one called demo. I can hit save, and it exports out that XML file. Now, I can select that demo file, just select it, right click, and go to open. and it gives us a nice view in Internet Explorer of, a great report of what's going on with that particular corridor. This report can be printed, you can email it to people, all people that are collaborating on the job, and they can start to talk about the values that are here. That's the process that I wanted to take you through so that you could see from a LiDAR point cloud that was scanned, that was a backpack scan or a mobile LiDAR point cloud that was generated from a LiDAR machine that's on top of a truck or a vehicle of some sort that drove it. From that LiDAR point cloud, we can bring it into InfraWorks. We can pull linear features so that we can start to target things and use that information inside of Civil 3D. We can also generate transverse features that allows us to pull points along that particular line or at a separate increment or at a station increment. And we can pull those points into Civil 3D so it'll generate our existing ground surface as a lightweight surface instead of generating something that is like heavier from the point cloud itself. And then we can start to target and use those lines to generate our lane widths for our rehab corridor. And then again, I just briefly went over the rehab parameters, but you can set those rehab parameters to what you need to perform the design that you're wanting to work on there on this project. This concludes the series covering this road rehab workflow. I hope that the information in this video has helped you to understand this step of the workflow I've been describing. Have a great day.